Check 1 2 3. Check 1. Online sounds, is it loud and clear? Is it loud and clear? You can reply in the chat. Check 1 2 3. Check 1. Online sounds, is it loud and clear? Is it loud and clear? You can reply in the chat. Check 1 2 3. Check 1. Online sounds, is it loud and clear? Is it loud and clear? You can reply in the chat. Check 1 2 3. Check 1. Online sounds, is it loud and clear? Is it loud and clear? You can reply in the chat. Check 1 2 3. Check 1. Online sounds, is it loud and clear? Is it loud and clear? You can reply in the chat. Check 1 2 3. Check 1. Online sounds, is it loud and clear? Is it loud and clear? You can reply in the chat. Check 1 2 3. Check 1. Online sounds, is it loud and clear? Is it loud and clear? You can reply in the chat. Check 1 2 3. Check 1. Online sounds, is it loud and clear? Is it loud and clear? You can reply in the chat. Check 1 2 3.
Right. This is just a check because there was a reverberation in the noise. Just to get check, is the same thing repeating over and over again? Just reverberation. I'll do one more check. Okay. Right. Okay. Good evening, everybody. Well, this is another session of final countdown. This is week number 3, day number 1, 2001 A-level paper. 2001 A-level paper. So let's go back to work. And we start with MCQs. Then one structured, one essay. Clear? One structured, one essay. Right. Okay. Have a look. Electron volt is a unit of. Electron volt is a unit of. Now what is electron volt? We have done this many times. Electron volt is a unit of what? Energy. Electron volt is a unit of energy. So here directly your answer is answer number 2. Directly your answer is answer number 2. There. So you will see me like a shadow here. You can call me dark man or black man or whatever, I don't know. So anyways, the board is clear for you. Right. Moving on to the next one. A sound with intensity 10 to the power minus 12 watt per meter squared. Remember, what do you mean by 10 to the power minus 12? We call this what? Goes. Okay, come outside and go. Okay, right. I'll explain again. Right. Have a look. Right. Okay, I'll explain again. Huh? Right. Careful. So, IO is 10 to the power minus E is given 10 to the power minus 8. 10 to the power minus 8. So, beta is equal to 10 log I over IO. So, here 10 log I is equal to 10 to the power minus 8. IO is 10 to the power minus 12. Okay, no? 10 to the power minus 12. Take this on top. You have 10 log 10 to the power 4. This comes here. Your answer is going to be 40 decibel. 40 decibel, answer number 3. 40 decibel, answer number 3. Okay? 40 decibel, answer number 3. Right. Third question. Two particles A and B have equal momenta. What do you mean by equal momenta? Same momentum. What do you mean by equal momenta? Same momentum. Same momentum means PA equals P. PA equals P. So MAVA equals MBVB. They are telling you particle B velocity is 4 times that of A. 4 times that of A. So MAVA 4 times that of A. MA is equal to 4 times MB. There you go. So from this you can build a small ratio. Small ratio is MA over MB is equal to how much? 4. MA over MB is equal to 4. Look at the board carefully. The ratio of the kinetic energy to kinetic energy B. Now look at the board carefully. What's the relationship between momentum and kinetic energy? I have taught you. P squared equal to me. P squared equal to me. Now, so P is same momenta, equal momenta, same momentum. So P squared equal to M1 E1 or EA, MA EA, P squared to MB EB. From this you simplify, these two are equal. 2 times MA EA equals 2 times MB EB. Simplify the relationship. EA divided by EB is equal to MB divided by MA. MB divided by MA. Carefully look. MB divided by MA, turn upside down. MB divided by MA is 1 over 4. Your correct answer here is answer number 1. Correct answer there is answer number 1. So third MCQ, answer number 1. Third MCQ, answer number 1. Okay, now? Don't forget, this is your relationship between linear momentum and kinetic energy. Relationship between linear momentum and kinetic energy. Okay? Right. Moving on. Moving on. Look at this. A uniform circular plate of radius capital R. So radius capital R is removed. What's the center of gravity of the plate? Now, very simple logic. Larger plate, center of gravity is here. When I remove this, what happens is, slightly the center of gravity will shift. If the center of gravity shifts, your correct answer is going to be what? Answer D. Answer D. But if you want to mathematically solve this, well, mathematically solving this is slightly tedious, but anyway, I'll do it for you all. If you look at this carefully, to take the full plate before cutting it, total mass, pi 2r squared into m dash, 4 pi r squared m dash. So where is 4 pi r squared m dash acting? Here you go. 4 pi r squared m dash into g. Wait. What about the removed mass? Removed mass is pi r squared m dash. Whenever you remove the mass, you have to mark the weight in the opposite direction. pi r squared m dash g. Vector changes. No? If your weight is adding, the weight is acting downwards. If you are removing the weight, you can change the direction of the vector. So new center of gravity, I'll take it here with new center of gravity. This distance we don't know. So take moments about g dash. Clockwise moments about g dash equals anti-clockwise moments about g dash. Clockwise moments 4 pi r squared m dash g into x. Anti-clockwise is r plus x. Pi r squared m dash g r plus x. Yeah, have a look. Simplify it. Pi r squared m dash g. Pi r squared m dash g. 4x equals r plus x. 3x equal r. X is equal to r divided by 3. So this radius divided by 3 is a very small distance. So most suitable answer is answer D. Remember, without the mathematics you can do this. When a mass is removed, center of gravity will slightly shift. Right there. When a mass is removed, the center of gravity will slightly shift towards the left. The center of gravity will slightly shift towards the left. The center of gravity will slightly shift towards the left. Okay? Right. Right, have a look. Consider the following made about infrared, ultraviolet, X-rays, radio waves and gamma rays. What can you say here? These are just electromagnetic spectrum. So all of them are electromagnetic waves, correct. All of them travel within the same speed in free space, yes, at the speed of light, 3 × 10⁸ meters per second. Radio waves have the longer wavelength, correct, correct. A, B, C all correct. Correct answer is answer number 5. Correct answer is answer number 5. That's very easy. Correct answer is answer number 5. Right. MCQ number 6. MCQ 6. The mercury column rises in a mercury glass thermometer when the temperature is raised. The most appropriate reason. Now we know this from thermal expansion. Why does it rise? That's very simple. That's because mercury is expanding more than glass. Glass expands less than mercury. Very simple. Glass expands less than mercury. That is why you can see what? Mercury rise. Right there. We can see mercury rise. We can see mercury rise because mercury is expanding more than glass. Mercury is expanding more than glass. Okay. The electrical energy stored in 1 microfarad capacitor across 2 volt cell. So there is a cell connected across a capacitor. So the complete voltage of the cell will be acting across the capacitor. No? So you can easily say the energy stored is equal to half CV squared. Half capacitance is 1 microfarad. Voltage is 2 squared. 2 × 10⁻⁻6 joules. 2 × 10⁻⁻6 joules. Correct answer, answer number 3. 2 × 10⁻⁻6 joules. Correct answer is answer number 3. Right. Moving on. Mass and radius of Earth m and r, escape velocity of a rocket. Right. What do you mean by escape velocity? We are projecting this mass so it never reaches the Earth back again. So it never reaches the Earth back again. That means it just reaches infinity. It just reaches infinity. I am just showing the proof. Otherwise 2gm divided by r square root directly you can get. So I can apply here total energy at A equals total energy at infinity. Total energy at A is gravitational potential energy at A plus kinetic energy at A. Total energy at B is gravitational potential energy at B plus kinetic energy at B. Gravitational potential energy at A is minus GME simple M over R. Kinetic energy is half M1 V escape squared. Gravitational potential energy at infinity, this is infinity, this is infinity. Gp is also 0, kinetic energy is also 0. Simplify the calculation. Half M1 V escape squared GME M1 divided by R. GME M1 divided by R. Okay, carefully look. M1 cancel off. Escape velocity is 2 GME divided by R whole thing square root. 2 GME divided by R whole thing square root. So here this answer is the valid answer. This answer is the valid answer. Answer number 1. Answer number 1. Right there. To escape the Earth's gravitational field means, to escape the Earth's gravitational field means, it must reach infinity. It must reach infinity. It must reach infinity. Okay? It must reach infinity. We can apply law of conservation of energy. We can apply law of conservation of energy to obtain the relationship. To obtain the relationship. To obtain the relationship. Okay? Right. A proton is fired to an atomic nucleus. Proton is positively charged. Atomic nucleus also contains protons and neutrons. So atomic nucleus is also positive. Which part is not possible? Not possible. So positive can repel, it can go away, diverge, but it can never attract. S is impossible. S is impossible. Right there. Protons are positively charged. Protons are positively charged, while the nucleus also is positively charged. While the nucleus also is positively charged. While the nucleus also is positively charged. Therefore, they can never attract each other. They can never attract each other. Okay? They can never attract each other. Right. Okay. So these are O and a not. So OR gate with a NOT gate, that's got NOR gate. NOR gate. OR gate with a NOT gate. OR gate with a NOT gate. OR gate with a NOT gate is going to be answer number 5. Answer number 5. Right there. The NOR gate can be represented. The NOR gate can be represented with a OR gate and a NOT gate. With a OR gate and a NOT gate. Very basic logic gates. With a OR gate and a NOT gate. Right. In the ECPHYSICS, V represents velocity, A represents acceleration. What is A and J? So V to the power I, K, A to the power J. V is velocity, LT minus 1 to the power I. K is dimensionless. A is acceleration, LT minus 2 to the power J. S is displacement, L. So these very basic units and dimensions time you have done these things. L to the power I, T to the power minus I, L to the power J, don't forget here 1, T to the power minus 2J, right. Now if both sides are equal, we can say left hand side powers and right hand side powers are equal. So what we can do is, we can consider the powers of L. I is equal to J plus 1. I minus J is equal to 1, equation 1. For T, minus I equals minus 2J. I is equal to 2J. Substitute there. 2J minus J. That is equal to 1. J equals 1. J equals 1. I equals 2. I equals 2. J equals 1. I equals 2. J equals 1. They are asking I and J. Answer is answer number 3. Answer is answer number 3. Answer is answer number 3. Work with me, huh? If you have not done the work with me quickly. Right. A train travels along a straight track. Next one. Train travels along a straight track. Another train travels in the same direction behind the first train at the same speed. Train number A is traveling with velocity u. Train number B is traveling behind the first train with velocity u. Remember, between them there is no relative motion. First train will act like a source, blow a whistle, frequency f. They are asking the second passenger here, what will he hear? F dash. F dash. So all of you all know the basic rule, no? F dash is what? Velocity of sound with respect to observer. Velocity of sound with respect to observer. So who is the source, who is the observer? Yes. Sorry. Here. Here we can say source, observer, right. So velocity of sound with respect to observer. Sound going that way with respect to observer, V plus U. Velocity of sound with respect to source, same V plus U into actual frequency F naught. These two cancel off, F dash equals F naught. That means actual frequency, apparent frequency, both are what? Same. Correct answer is answer number 3, right there. There is no relative motion between the observer and the source. There is no relative motion between the observer and the source. There is no relative motion between the observer and the source. Therefore, the actual frequency and the apparent frequency will be the same. Therefore, the actual frequency and the apparent frequency will be the same. Therefore, the actual frequency and apparent frequency will be the same. Done, no? Right. Okay. A 50 centimeter long cylinder, you can see 2000 paper done, 2002 paper done, 2001 paper, you are easily cruising. That's experience. A 50 centimeter long hollow cylindrical tube open at both ends is placed in air. So both ends placed in air. There you go. A sound source that produces pure note is placed adjacent to one of the open ends. The frequency emitted by the sound is increased gradually from a low value of 320, the tube resonates. So the first time this tube resonates from a low value, that's first harmonic. If I draw this for you, a fundamental harmonic, fundamental frequency. So here, fundamental frequency, remember, there is an N correction. But in our calculation, we ignore the N correction. 0.5 meters. Calculation, we ignore the N correction. Right. What is the speed of sound? So fundamental frequency F, V over 2L. How do I get this? Quarter, lambda divided by 2, that's equal to L. So lambda is equal to 2L. V is equal to F lambda. V is equal to F2L. So F equals V over 2L. Frequency 320 Hertz. Velocity of sound in air we don't know. 2 times length is 0.5. Neglecting N correction. 2 times 0.5 is 1. So velocity of sound in air is how much? 320 meters per second. 320 meters per second. Okay, now 320 meters per second. Question number 13. Question number 13. Right? Question number 13. So do quickly. Now increase the speed. Do quickly. Right. Okay. Question number 14. Right. Velocity of sound of a gas at 27 is V. So you know the equation. So V proportional to square root of T. 27 degrees Celsius is 300 Kelvin. There you go, equation number 1. Now I am doubling the velocity of sound. 2V proportional to temperature, I don't know. Kelvin temperature. Second equation divided by the first equation, 2V divided by V, T divided by 300 square root. V cancel off. 2 times T over 300 square root. Now what do? Square both sides. 4 equals T over 300. T equals 1200 Kelvin. I want in Celsius. So 1200 minus 273. 273. So what's your answer there? 273. 927 Celsius. 927 Celsius, correct answer number 4. Correct answer is answer number 4. Correct answer is answer number 4. Right. Okay. Right. Moving forward. Question number 15. A convex lens of focal length 25 is kept in contact with a concave lens of focal length 10. So convex lens is in contact with a concave lens. Focal length of convex lens minus 25, concave lens plus 10. Power of the lens combination. First find the theory. 1 over equivalent is 1 over focal length of convex, 1 over focal length of concave. Focal length of convex minus 25, focal length of concave plus 10. Common denominator is going to be 50 minus 2 plus 5. Equivalent focal is 3 over 50. Right. Turn upside down. F equivalent is plus 50 over 3 centimeters. Convert to meters. Divide by 100, 300. 1 over 6 meters. What can you say about the power? 1 over F equivalent. 1 over 6. Minus 6 diopter. Minus 6 diopter. Correct answer is answer number 2. 15 answer number 2. Right there. We find the equivalent focal length. We find the equivalent focal length. We find the equivalent focal length. And from the equivalent focal length, we can find the equivalent power. We can find the equivalent power of the combination. We can find the equivalent power of the combination. Right? Equivalent power of the combination. Right. MCQ 16. A viscous force acting on a sphere moving in a fluid. What are they talking about? They're talking about Stokes' equation. Stokes' equation. Force is proportional to eta RV. Directly proportional to the velocity, correct. Directly proportional to the mass. Inversely proportional to the radius. Now what are they asking you here? Viscous force acting on a sphere moving in a fluid. moving in a fluid? Depends on. So you know eta, you know r, you know v. It's not terminal velocity, it's viscous force. So it does not depend on the mass, depends on the speed and the radius too. Radius, right? Only correct statement is answer A. Only correct statement is answer A, right there. According to Stokes' law, the viscous force depends on eta r v. The viscous force depends on eta r v. The viscous force depends on eta r and v. Okay. Work. Next one. A monochromatic ray of light undergoes minimum deviation after passing through a prism. Very easy work. Angle of deviation produced by one of the prism surface is 20. What's the angle of minimum deviation of the ray? Now, equilateral prism. Normally, remember, I1 equal I1 equal I2, R1 equal R2. I1 equal I2, R1 equal R2. So deviation is normally I1 plus I2 minus R1 plus R2. So at minimum deviation, at 2I1 minus 2R1. 2 times I1 minus R1, right? So if I draw the ray diagram here, look, light ray coming, here it's I1, here it's R1, this is going to be I1 minus R1. This is R2, this is I2, this angle is I2 minus R2. So minimum deviation I1 minus R1 equals I2 minus R2. Deviation from one end is 20. So total minimum deviation is 40. Correct answer is answer number 4. So deviation from one surface is I1 minus R1, that's 20. So minimum deviation means double. Minimum deviation means double. Question number 17, answer number 4. Question number 17, answer number 4. This is your prism angle. Right there. At minimum deviation, the total deviation will be double the deviation from one surface. The total deviation will be double the deviation from one surface. Double the deviation from one surface. Okay? Right. Right. Look at this. A person who is long-sighted has a near point 50. Very good. What spectacles are required for him to view objects at 25? So what happens? The image must form where the eye can see. So object is kept at 25. Image from the first lens is actually the object for the eye. Where can the eye see? I can see at 50. I can see at 50. So apply lens equation. 1 V equal 1 U plus 1 F. Object is 25. Image is 50. Length of the lens. Common denominator 50, 1 minus 2. Turn upside down. Minus 50 centimeter. Remember, minus 50 means what? Convex lens. So converging lens of focal length 50. Correct answer is answer number 3. Correct answer is answer number 3. Right there. When we place the object at 25, the image must form where the eye can see. The image must form where the eye can see. Image must form where the eye can see. Image must form where the eye can see. Okay, no? Right. Okay. An electric heater is used to raise the temperature of water from 20 to 30. Heat given equal heat absorbed. So heat given equal heat absorbed. Now I divide both sides by time, then becomes rate. Rate of heat given equals rate of heat absorbed. Rate of heat absorbed. So rate of heat given is the power of the heater. Rate of heat absorbed is mW CW delta theta divided by T. Rate in which water 1 kilogram per minute converts to seconds. Specific heat capacity 4200, change in temperature is 10. 30 degrees minus 20 degrees is 10. From this 700 watt, that's about 0.7 kilowatt. 700 watt, 0.7 kilowatt, answer number 3. 0.7 kilowatt, answer number 3. So you can see without any much effort you can solve this. Any much effort you can solve this quickly, sometimes from your O-level knowledge. Right? MCQ 20. Right. Relative humidity inside a closed chamber can be increased by adding water vapor to the chamber. Yes. RH is equal to mass of unsaturated vapor into divided by mass of saturated vapor into 100. So by adding water vapor means M increases. M increases means RH will increase. Correct state A is correct. Second one, decrease the temperature. When I reduce the temperature inside, what happens? The mass of water vapor required to saturate will also reduce. Mass of water vapor required to saturate will also reduce. Temperature reduces. MS will reduce. MS reduces. RH will what? Increase. Correct. B is correct. By decreasing the volume of the chamber. By decreasing the volume of the chamber. Look at the board carefully. Now RH you can also write in terms of H. M over V. MS over V into 100. MS over V into 100. Look at the board carefully. So at a given temperature, this value is constant. When I reduce the volume, density increases, H increases, RH will also what? Increase. H increases, RH will also increase. Which means C is correct, A, B, C all are true. A, B, C all are true. Look at the board now. If I add water vapor, M is increasing, RH will increase. If I am reducing the temperature, saturated vapor mass will reduce. T reduces, MS reduces, RH will increase. Next is decreasing the volume for a given temperature. For a given temperature, this is constant. This is constant. So when V reduces, the density will increase. H, absolute humidity will increase. When absolute humidity increases, RH will also what? Increase. RH will increase. A, B, C all correct. A, B, C all correct. Right. So you can see now these things. So what can you say? MCQ number 1 to MCQ number 20 easily all solved. If you look at the timing, even I solved it by around 35 minutes we solved. But you all don't have to explain now, I'll do, you all can quickly solve it even further. So you can see the trick here. 2-hour paper, within the first 35 minutes, 20 MCQs are over. First 35 minutes, 20 MCQs are over means you can move forward. Very quickly you can move forward. Yeah. So my suggestion to you also, try to break the M's like this. Now I'm doing the papers also what? 20 MCQs, one structured, one essay. Then 20 MCQs, one structured, one essay. So try to, without continuously doing the MCQs, then go into structured essay and essay. Anyway, for your breaking down a big problem set to smaller problem sets, you can perform well. If we did all 60 MCQs today, you will get fed up. But you won't do also. But 20 MCQs, one structured, one essay, you will do. So like that, even in the exam paper, you manage your time by doing things that you can do quickly, or you reduce the quota. 50 MCQ means you reduce it to 20, 20, 10. Or 15, 15, 20. Or best is 20, 20, 10. Yeah. From there you can, then the last 10 means less pressure. You can easily do. Right? Anyways. Moving on. Moving on. So this is the structured essay question. Structured essay question, read. Determine the coefficient of static friction. Determine the coefficient of static friction acting on the object. Acting on the object when a uniform block of weight is hooked. Light spring, a meter ruler, 5 weights, 0.1, 0.2, 0.3, 0.4. In order to calibrate the spring, one end of the spring is attached to a fixed point and the other end is loaded. The force mg plotted is given as indicated below. The graph is given here. Graph is given here. Length into mg. Be careful with the axes. Now the first thing that you should note is the axes. Note the axes carefully. Note the axes carefully. There you go. L and mg. Mg means Newton. Right. Okay. Moving on. When the block is hung from the spring, the length of the spring was found to be 30 millimeter. Length of the spring was found to be 30 millimeter. Determine the mass of the block using the above calibration. Right. 30 millimeter. Here you go. 30 millimeter. Here you go. What's the weight? Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here 1.5 is there. So mg is 1.5 Newton. M is equal to 0.15 kilogram. 0.15 kilogram. So you can go back here and then quickly you can put the answer 0.15 kilogram. That's it. Right. Now look at the board carefully. Simple question. Now the block is placed on a horizontal table and now we are pulling it. Okay. Write down the expression which relates the limiting friction force with the normal reaction and the surface. So limiting friction force equals mu times normal reaction. Mu times normal reaction. There you go. Same symbols I have used. Same symbols we have used. Right. Moving on. The above experimental procedure in B is repeated by placing each weight on top. One weight on top of the other weight means what happens? Normal reaction will increase. Normal reaction will increase means friction force will increase. Right. Now look. Block without any weight. Block without any weight, L equal 25 millimeter. Go back to the table. Go back to the table. L equal 25 means 1, 2, 3, 4, 5. One Newton. This is the pulling force. Huh? This is the pulling force. So go back. Right. So what is your limiting friction force? Well, the pulling force is going to be 1 Newton. No? What is your normal reaction? What is your normal reaction? Block with only weight. So what's the weight of the block? 0.15. 0.15. What is your normal reaction? 1.5 Newton. 1.5 Newton. Right. Block plus 0.1 kilogram. 0.15, 0.1. 0.25. 2.5 Newton. L is 30. Go back to the table. L is 30 means 1.5 Newton. So the pulling force is 1.5 Newton. Huh? Pulling force only is marked there, 1.5. Block plus 0.2. 2.5 plus 2, 3.5. L35. Go back. L35. L35. Two Newtons. So pulling force is 2 Newtons. Here, if you read the question here, they are given you whatever force you are pulling on is given. Nah? So you are pulling here, pulling force is 2 Newton. Whatever force you are pulling. Your pulling force is 2 Newton, 2.0 Newton. Here 3, 4.5, 41 millimeter. 41 millimeter. 41 millimeter. How much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2.5. 1, 2, 3, 4. 2.5, 2.6, 2.7. 2.7, na? 2.7. 2.7 Newton. 2.7 Newton. Right. 0.4 kilogram. 0.4 kilogram. 4 Newton. 5.5. 48 millimeter. Go back to the table. 48 millimeter. 48. 41, no? Right. No, I think 41 should be corrected. 41. Early one, 41 millimeters. No? Yes. I think taken 41. 41. Careful. 2.6. 2.6. Not 2.7, 2.6. 2.6. 48 millimeter. 48 millimeter. Go back. 41, 42, 43, 44, 45, 46, 47, 48. 3.2, 3.1, 3.2, 3.25, 3.25, 3.25, I know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3.1, 3.2, 3.25 in between. So here 1 decimal 3.25, let's say 3.3. Next is 5, 6.5 Newton, 55, go back to the table. 55. 4. So I have done is for every force we have found the normal reaction. This force is found at the limiting friction. The above experiment is repeated by placing each weight on top of the block, and the corresponding weight is found. Here, this was done. Now the block is placed and the spring is pulled horizontally as the block just starts to slide. Just starts to slide. Just starts to slide means limiting. Right, limiting friction. When this occurs, the length is measured. So the force corresponding to the limiting friction moment we know. Here, force corresponding to the limiting friction point we know, right? Complete the above table by calculating R values and obtaining corresponding F values. Done. Mark the above FR pairs on the given grid. Right. So we can mark no. First one, normal reaction 1.5. Normal reaction 1.5. Then you have normal reaction 2.5. Normal reaction 5. Normal reaction 4.5. Normal reaction 5.5. Normal reaction 6.5. Corresponding force values. 1.5 is 1. 2.5 we found earlier now. 1.5. 3.5 to 2. Next, 4.5 to about 2.6. . 2.6 is here. Four point five, 2.6. Right. There you go. 2.6. Right. Next one. 5.5. 5.5. 3.3. 5.5, 3.3. 5.5, 3.3. Let's find 3.3 will first. This one also I must correct, I think the top one. Two point six. Right. Blue one is better. Right. 3.3. 3.1, 3.2, 3.3. 5.5. Right. 6.5. 6.5 how much? Can't remember. 6.54. 6.54. 6.5 is 4. Right. Then what? Mark. Using crossers. We'll mark with crossers. Easy. Then what? Crossers. Right. Okay. I erased it, no? 4.5. 4.5, 2.6. Right. Okay. Everything is marked. Then what? Draw the best straight line through the points. So best fit line means keep the ruler, check and see which line will evenly distribute the points above and below the line. Above and below the line. So if you draw this line, best fit line, I hope you use the ruler to draw this. Here, if you draw it, ruler tool. Must keep a ruler and draw. So it will go through it will be a line like that. Uniformly distributes. Here I am using freehand sketch, but keep a ruler and draw. Keep a ruler and draw. Best fit curve you will get. Right. Find the gradient of the graph and hence find mu. Right, now what's the gradient? Gradient means y2 minus y1 divided by x2 minus x1. I can take this point. What's the other point passing through? If I look at a point far away, remember you must draw this. I hope you all drew it correctly. This evil spot of bother because we didn't draw it clearly here. Right. So one straight line will come like that. Maybe this line is even slanted, we don't know. But looking at it, it's not best fit. It should be distributing above and below correctly. Above and below correctly. Slant the curve more. Let's see. About these two, so above and below, best fit curve will come. So we can take this point, 2.5 comma 1.5 xy. Here 5.5 comma 5.5 comma 3.3. y-axis force, x-axis normal reaction. So if you apply y2 minus y1 divided by x2 minus x1, this takes time. Huh? That's going to be opposite over just a normal force over normal reaction is. So what is y2? y2 3.3 minus 1.5. 3.3 minus 1.5. 5.5 minus 2.5. Right, no? Simplify this. 1.8 divided by 3.0. Correct answer is 0.6. See whether you got this. Correct answer is 0.6. Okay. So I roughly drew it and got this answer, which means you can also get it correct. What would be the best procedure to measure L in using the meter ruler? In using the meter ruler. So L is what? Extension. No? So what will be the most suitable method? Block is there. Block is there. You can put an indicator pin here. And here you can mark a linear scale. You can put a linear scale at the bottom. And here, no force applied, it's connected to a reading. And when you extend it, different reading. Difference in the readings will give you what? Extension. Difference in the readings will give you extension. Okay. Right there, no? The first step is when the indicator pin coincides with the reading initially without force being applied, that's equal to R1. The reading on the scale, when the object is just to move, when the object is just about to move, let's say reading is R2. Difference in the reading, R2 minus R1, will give you extension, and that will give you the force. Clear? That will give you the force. Right, no? We can find the force. You know the extension, we can find the force. Okay, no? Right. So that structured essay also done, na? It's a good structured essay, but effectively we have done it. Okay. Essay. Right. Bernoulli's equation is given by this, where all the symbols have their usual meaning. State conditions to apply Bernoulli's equation. Not discuss. incompressible streamlined flow. Streamlined flow, very basic knowledge but important. Non-viscous, incompressible, streamlined flow. Right. Show that the above equation is dimensionally correct. P plus half rho V squared plus rho GH, that is going to be constant. Right. So what's the dimensions of P? Pressure, no? ml minus 1, T minus 2. Then find the dimensions of half rho V squared. Half separately, rho separately, V squared separately. No dimensions. ml minus 3, LT minus 1 squared. ml minus 3, L squared T minus 2. ml minus 1, T minus 2. There you go, half rho V squared. That is also same dimensions as pressure. Rho GH. Rho ml minus 3 LT minus 2 into L. ml minus 1 T minus 2. All have dimensions of pressure. Therefore, dimensionally correct. Dimensionally correct. Dimensionally correct. Right? Okay. Read the question. An insecticide sprayer shown in the figure has a pump with diameter 60 millimeter. The diameter of the outlet is 2 millimeter. Insecticide level is 90 millimeter below. Assume that the pressure at A is same as the pressure at B. So here pressure and here pressure both are what? Same. I'll name it P1 with easier. Right. And the air behaves according to all the conditions you mentioned above. Calculate the minimum speed which piston P should be pumped to push if the air jet is to contain insecticide. Remember this. Air is coming from here to here. Creates a pressure difference, liquid will go up. Creates a pressure difference, liquid will rise up. This is liquid going up. Remember, still not mixing. If mixing takes place, you can't apply Bernoulli's principle. Mixing occurs means you can't apply Bernoulli's principle. There. Mixing occurs, you can't apply Bernoulli's principle. So I'll solve this in the board easier. 6290. Right. Look at the board carefully. Right. Now here is your tube. Here is your tube. Right. Right. Carefully, huh? The liquid is going to rise. Liquid is going to rise. 20 millimeter. Remember, air and this will not mix. After mixing, you can't apply Bernoulli's principle. Huh? So if I consider streamline up to there, here pressure P1, here pressure P1, here velocity V1, don't forget here pressure P3, velocity V3. Right. Here diameter is 60 millimeter. Here diameter is 2 millimeter. Right. Apply equation of continuity using equation of continuity. using equation of continuity. Here we can say A1 V1 equals A2 V2. Please look at the board now. A1 V1 equals A2 V2. Area A1 is pi, radius 30 millimeter convert to meter squared, velocity V1. Here pi 1 10 to the power minus 3 squared V2. Simplified, 900 V1 equals V2. V2 is 900 V1, right. Equation 1. Now apply Bernoulli's principle, because whatever velocity I am pushing here and the velocity there, both are same. So for air, I apply Bernoulli's principle. Apply Bernoulli's equation. If you apply Bernoulli's equation, P1 plus half density of air V1 squared, same level, I can take this as the GP equals 0 line, easy no? P3 plus, pressure P3 plus half rho V3 squared, half rho V3 squared, right. Look at this carefully. Velocity V3, take this to the other side. P1 minus P3, P1 minus P3, half rho V3 squared, half rho V1 squared, half rho V3 squared minus V1 squared, P1 minus P3. Now what have they given you? What have they given you? Density of insecticide 1000, density of air is 2. P3 plus H insecticide G is equal to P1. Right? P3 plus H insecticide G is equal to P1. Pressure. From this you can get P1 minus P3 H rho I G. This is equation 2, this is equation 3. 2 and 3 are equal. Hi rho I G half rho A V3 squared minus V1 squared. Carefully simplified. 90 millimeters convert to meters. Insecticide is 1000, G is 10. Half density of air is 2. V3 is equal to 900 V1 squared minus V1 squared. Carefully look. 900 equals, look at the board now. 900 squared V1 squared minus V1 squared. Looking at this, what can you say? 900 squared V1 squared is very much more greater than V1 squared. 900 squared V1 squared is approximately, 900 squared minus V1 squared. That is approximately 900 squared V1 squared. Substitute. 900 equal 900 squared V1 squared. 1 900 cancel off. V1 squared is 1 over 900. V1 is equal to 1 over 30. 0.033 ms minus 1. 0.033 ms minus 1. Write down the ones who need it now. What have I done? I have applied Bernoulli's principle for air. Then I apply the pressure balance. Bernoulli's equation of continuity. Then Bernoulli's equation. This I can substitute. Here actually it's V3, yeah? V3. V3 is 900 V1. Wherever is V3, I can substitute 900 V1. 900 V1 squared. 900 squared V1 squared minus 1, the negligible. 0.033 meters per second. Clear? 0.033 meters per second. Part A done. So once you need to take a photograph, here you go, look. First part, I am applying Bernoulli's equation along a streamline. I am applying equation of continuity. Second one, I am applying pressure balance. P1 minus P3, I equate it. Then we can easily substitute here. From here we can find the velocity. 0.033 meters per second. Right. Final question they are asking you. If the net resistive force acting on the piston is 20 Newton, piston is there, I am applying resistive force is 20 Newton and is traveling with 0. What is the applied force? Apply F equal ma forward. External force minus resisting force, no acceleration. External force is also 20 newtons, there you go, in the forward direction. Right? Okay? Right. Okay then. If you look at it, we have applied Bernoulli's principle along the streamline. Remember, these just to rise. When mixing takes place, you can't. Here you can't apply Bernoulli's turbulent flow. Here to here air, here liquid just rises. You apply. Mixing occurs, never apply Bernoulli's principle. When mixing occurs, there is turbulent flow. You have to apply this for streamline flow, not for turbulent. So you can't apply Bernoulli's principle. Yeah. Okay, no? Right. Okay then, 2001 exam paper, week 3, day 1 complete. I'll catch you tomorrow with 3, day 2. Stay home safe, keep working.